1,
2,
3, let's go!
So in this unit, we are going to be talking about trigonometric integrals using substitution, or basically trig integrals with higher powers. So basically in this unit, we're going to work on integrals that look like this, like these basically. So we're going to work on integrals that look like this: sine x to the n power times cosine x to the n power dx. We're also going to work on the integral of tan x to the n power times secant x to the n power dx. Also, we're going to work on integrals that look like sine x to the n power dx, cosine x to the n power dx, tan x to the n power dx, and secant x to the n power dx. Also, all of the exponents, like all the powers, m and n and m and n and all of these, all the powers, they're going to be greater than or equal to 1. Usually greater than 1, but it could be equal to 1, but all the powers are going to be greater than or equal to 1. That's why I said higher powers and stuff. So for topic 1 of this unit, I'm going to be doing 3 videos on integrals that look like this: the integral of sine x to the n power times cosine x to the n power dx. Topic 2, I'm going to be doing 3 videos on integrals that look like this: the integral of tan x to the n power times secant x to the n power dx. And for topic 3, I'm going to do 2 videos on integrals that look like this, which are basically, they're basically the individual trigonometric integrals. So the integral of sine x to the n power dx, the integral of cosine x to the n power dx, the integral of tan x to the n power dx, and the integral of secant x to the n power dx. Alright, so like I said in the previous clip, so now in this video we're going to be working on topic 2. Topic 2 in this unit, I guess, is scenarios that look like this: integrals of tan x to the n power times secant x to the n power dx. So we're going to be working on integrals that look like this. When it comes to integrals that look like this, there are 4 possible scenarios. Scenario 1 is where m, which is the exponent for the tan function, and n, which is the exponent for the secant function, are both odd. Scenario 2 is when m and n are both even. Scenario 3 is when m is odd but n is even, and scenario 4 is when m is even and n is odd. So that's what we're going to be working on in this video. Okay, so here are some really important things to remember for this topic. I'm going to be referring to certain things throughout the video as equation 5, equation 6, rule number 1, and rule number 2. So these are equations 5 and 6, and these are rule number 1 and rule number 2. So equation 5 and equation 6 are just trigonometric identities. Equation 5 is tan x squared is equal to secant x squared minus 1. Equation 6 is secant x squared is equal to 1 plus tan x squared. Rule number 1 and rule number 2 are just algebra and stuff, but it's important for this, topic, so just a reminder. So x to the power of a plus b is equal to x to the power of a times x to the power of b. And also, in reverse, x to the power of a times x to the power of b is equal to x to the power of a plus b. So if a plus b were numbers, right, and x was raised to the power of a plus b, this term can be broken down into x to the power of a times x to the power of b. And also, if it's x to the power of a times x to the power of b, to combine this, you can add the exponents, x to the power of a plus b. But if they're added, always remember that when you break it down, you multiply it. And if it's being multiplied and you're combining it, just remember that the exponents, you add them. So that's rule number 1. Rule number 2 basically is, this is rule number 2. It's also just another algebra thing. X to the power of a and all of this whole term to the power of b is equal to x to the power of a times b. And also in reverse, x to the power of a times b is equal to x to the power of a and this whole term raised to the power of b. So if it's a term raised to the power of something, and that whole term that's raised to the power of something, that whole term is raised to another power, to combine it, you can combine it such that it can be x raised to the power of a times b. They're times if it looks like this. If it's x to the power of a number and the whole term is to the power of another number. Then to combine them, you can do x to the power of a times b. The exponents are times. And also to like break it apart and stuff like that, x to the power of a times b, if the exponents are times, you break it up like this, like x to the power of a and this whole term to the power of b. I'm going to do a little example of rule number 1 and rule number 2. I already did an example like this in the previous video, so I'm just going to insert the clip where I did an example of rule number 1 and rule number 2 now. Alright guys, so like it said in the previous clip, we're going to be working on scenario 2 in this video. Scenario 2 is when m and n are both even. M is the exponent for the tan function, and n is the exponent for the secant function. So we're going to do an example for the scenario. Example 1 is the integral of tan x to the 4th power times secant x to the 8th power dx. As you can see, m, which is the exponent of the tan function, is 4, and that's an even number, and n, which is the exponent of the secant function, is 8, and that's also an even number. Alright, so per usual, the steps are going to be on the left side, the word shown is going to be on the right side, so let's get into the video. Alright, so for step 1, what we're going to do is we're going to break off 2 powers of the secant x term, and we're going to put it into this format. Secant x to the something power times secant x squared, then we rewrite the integral. So what do we have so far? So we started off with tan x to the 4th power times secant x to the 8th power dx. So we're going to take this secant x to the 8th power term and we're going to break off 2 powers from this term. So secant x to the 8th power dx, that's equal to secant x to the power of 6 plus 2, because remember 6 plus 2 is 8 and we have to break off 2 powers, so we have to break this down into the power of 6 plus 2. It has to be something plus 2 because we have to break off 2 powers. So if you recall rule number 1, secant x to the power of 6 plus 2, since this these exponents are added, it can be broken down like this. It can be broken down into secant x to the 6th power times secant x squared. So since secant x to the 8th power can be broken down into secant x to the 6th power times secant x squared, we can rewrite the integral as this. The integral of tan x to the 4th times secant x to the 6th, let me write that x a little better, times secant x squared dx. Alright, so that's it for step 1. Alrighty, now let's go to step 2. So for step 2, we have, so we're going to rewrite the secant term where the exponent does not equal 2, in the following format. Secant x squared and all of this to the power of something. You can skip this step if both of the secant terms are secant x squared times secant x squared after you do step 1. If they both look like this, you can skip this step. But yeah, so let's get into it. So what do we have so far? We have the integral of tan x to the 4th times secant x to the 6th times secant x squared dx. This is the secant term where the exponent does not equal 2, because in this secant term the exponent does equal 2. So this is the secant term where the exponent does not equal 2, and we have to put it into this format right here. So secant x to the 6th, right? Secant x to the 6th, that's equal to, alrighty, now let's go to step 2. So for step 2, we have, so we're going to rewrite the secant term where the exponent does not equal 2, in the following format: secant x squared and all of this to the power of something. You can skip this step if both of the secant terms are secant x squared times secant x squared after you do step 1. If they both look like this, you can skip this step. But yeah, so let's get into it. So what do we have so far? We have the integral of tan x to the 4th times secant x to the 6th times secant x squared dx. This is the secant term where the exponent does not equal 2, because in this secant term the exponent does equal 2. So this is the secant term where the exponent does not equal 2, and we have to put it into this format right here. So secant x to the 6th, right? Secant x to the 6th, that's equal to secant x to the power of 2 plus 4. Now remember, we have to put it into this format, so it has to be 2 plus something, because we're trying to put it into the format of secant x squared to the power of something, so it has to be 2 plus something. So yeah, since 6 minus 2 is 4, secant x to the 6th can be broken down into 6 secant x to the power of 2 plus 4. Now, if you recall, rule number secant x to the power of 2 times 3. Because remember, we're going to be putting it into this format, so this applies to rule number 2 that I was talking about earlier. So secant x to the power of 2 times 3 is equal to secant x to the 6th power, because 2 times 3 is 6. And we have to get into the power of secant x squared to the power of something, so it has to be 2 times something. And 2 times 3 is 6, so that's why it's broken down like this. So if you recall, rule number 2, like I said, secant x to the power of 2 times 3 can be broken down into secant x to the power of 2 and this whole thing to the power of 3. So yeah, now it matches this format. Secant x2 to the power of 3, it matches the format of secant x squared to the power of something. Did I say secant x2? I meant secant x squared. Sorry. Secant x squared to the power of 3. That matches this format, secant x squared to the power of something. As you can see, the something, the box, is 3. So yeah, secant x squared to the power of 3. That's equal to secant x to the 6th. And yeah, now we're going to rewrite the integral, and where we put secant x to the 6th power, we're going to put secant x squared and all of this to the power of 3 instead of this. So let's do that. So now we'll have the integral of tan x to the 4th power times secant x squared and this whole thing to the power of 3 times secant x squared dx. All right, so then this is it for step 2. Now let's go on to step 3. Alrighty, so on to step 3. So for step 3, what we're going to do is we're going to rewrite the equation such that it looks like this. The integral of tan x to the whatever times the integral of secant x squared to the something times the integral of secant x squared dx. If it already looks like this, you can skip this step. This step isn't necessarily like necessary per se usually. It just like helps with the algebraic breakdown. And also, it already does look like this. It already looked like this after we did step 2. So we're pretty good. So we can kind of skip this step, because remember, after we did step 2, we had tan x to the 4th times secant x squared, all that to the 3rd power times secant x squared dx. So this whole shebang, basically, it's already in this format. So it's because tan x to the 4th power, that's the first term. Secant x squared to the something power, that's the second term. Then secant x squared, all that, that's the third term. Then dx is last off, of course, as it usually is. Well, not usually, as it always is. Dx is always at the end. Anyway, yeah, it's already in this format, so we can just skip this step. So I'll just put, we can skip this step because it is already in this format. Smiley face. Anyway, let's go on to step 4. All right, so let's get into step 4. So for step 4, if you recall equation 6 that I said from the beginning of the video, it was a trigonometric identity. Secant x squared is equal to 1 plus tan x squared. So we're going to rewrite the integral, and we're going to replace secant x squared to the power of something with 1 plus tan x squared to the power of something. So what do we have? What did we have originally? We had, well, not originally. What did we have in the previous step? What did we have in the previous step? We had tan x to the 4th power times secant x squared to the 3rd power times secant x squared dx. So we're going to take this right here, and we're going to replace this secant x squared to the power of something, this right here, this term, and we're going to replace it with 1 plus tan x squared. Yeah, but then I wanted to say this in the steps. When it says rewrite the integral and replace secant x squared to the power of something with 1 plus tan x squared to the power of something, I'm talking about this secant x squared term, like this one that this whole term is raised to the power of something, not this one that's next to dx, not this one. I'm talking about this term. That's why I put this little box here to like symbolize the secant x squared term that's raised to the power of something. We'll leave this term alone. We'll get to it later. But anyway, so secant x squared is equal to 1 plus tan. Why does the t look like that? Tan x squared. So when we rewrite the integral, we can rewrite it as tan x to the 4th times 1 plus tan x squared to the 3rd power times secant x squared dx. So yeah, in this step, all we did was replace this secant x squared term with this right here. So yeah. All right, so then that's it for step 4. Now let's go on to step 5. Alrighty, so for step 5, what we're going to do is we're going to substitute using u. We're going to make u equal tan x, then we're going to take the derivative, which is du over dx. So what we had before, we had the integral of tan x to the 4th times 1 plus tan x squared and all that to the power of 3 times secant x squared dx. Right? So, so what we have to do is we're going to make u equal tan x. We're going to do a little u substitution. So u is equal to tan x. Now we have to take the derivative of this. Hopefully you guys remember your trigonometric derivatives and stuff. And so since u equals tan x, du over dx is equal to secant x squared. And, oh, by the way, we also have to solve for du. Okay, hold on. Let me put next. Solve for du. I'll probably put like down here or somewhere that we have to solve for du as well. I forgot to write that, but whatever. I'm gonna like edit the video and put it here. Anyway, we have to solve for du. So we have du over dx equals to secant x squared. So we can make this a fraction and then do du over dx is equal to secant x squared over 1. And then we cross multiply. And then we get du times 1 is equal to secant x squared dx. And since anything times 1 is itself, we get du. Sorry, trying to put the thing up so you guys can see. I don't know why it's blurry at the end of the screen. Anyway, well, actually, let me keep it like that. Well, no, that's fine. Anyway, let me just put it this way. Anyway, so since anything times 1 is itself, we're going to, du times 1 is equal to secant x squared dx can just be written as du equals secant x squared dx. And as you can see here, like I said, next solve for du. As you can see here, we solve for du because we have du is equal to secant x squared dx. So that's pretty much it for step 5. We just have to define u and du, basically. So u is equal to tan x and du is equal to secant x squared dx. So yeah, that's it for step 5. Let me put this here straight. And now let's go to step 6. Alrighty, so now let's go into step 6. So for step 6, we're going to rewrite the answer from step 4 in terms of u and du. And to rewrite in terms of du, we solve for secant x squared dx. Now, du already does equal secant x squared dx, but I always put this little tidbit just in the sense of like, in case of like, say for example, right, we had something like du times like 3 is equal to 4 times secant x squared dx or something, just something like that. We would have to solve for secant x squared dx, and so we would have to get this right here, secant x squared dx. We would have to get this alone, and to get this alone, you would divide by 4 on both sides, divide by 4 on both sides, and you would get 3 over 4 times du is equal to secant x squared dx. And then, so now we've solved for secant x squared dx because secant x squared dx is by itself. So we have 3/4 du is equal to secant x squared dx. That doesn't apply to this particular scenario because as we just saw with step 5, this doesn't really apply to this video because as we just saw for step 5, du is actually equal to secant x squared dx, but just in the case or in the event that it wasn't, you have to solve for secant x squared dx, but it's already solved for secant x squared dx here. So yeah, but that's the only reason I wrote the thing that's in parentheses. But anyway, let's get into it. So we have the integral of tan x to the 4th times 1 plus tan x squared to the 3rd power times secant x squared dx, right? That's what we have so far. So we're going to rewrite this in terms of u and du. And as we established from the previous step, u is equal to tan x, and then du is equal to secant x squared dx. So we're going to rewrite this entire integral in terms of u and du. So everywhere we see tan x, we're going to put u. Everywhere we see secant x squared dx, we're going to put du. So if we were to do that, let me put some boxes to kind of illustrate my point a little more. Tan x to the 4th, instead of tan x to the 4th, we would put u to the 4th, because everywhere we see tan x, we're going to put u. And then 1 plus tan x squared, and this whole thing to the 3rd power would be 1 plus u squared to the and the whole thing to the 3rd power. And then secant x squared dx would just be du. So like I said, let's review. Tan x to the 4th, that's now u to the 4th. 1 plus tan x squared, and this whole thing to the 3rd power is now it's written as 1 plus u squared, and this whole thing to the 3rd power. And then secant x squared dx is now du. So just to, rewrite it to make it look more pretty and presentable. U to, now it can be written as u to the 4th times 1 plus u squared, and this whole thing cubed times du. So yeah, that's what we have now for step 6. All right, so now let's go on to step 7. All right, so for step 7, we're going to multiply all the terms out, and then we're going to rewrite the equation. So what do we have from step 6? We have u to the 4th times 1 plus u squared, and this whole thing cubed du. So we're going to take all of the terms in the integrand, and we're going to rewrite the equation. So let's do this. U to the 4th times 1 plus u squared to the 3rd power We're going to multiply all this out. So we can start off with 1 plus u squared and that whole thing cubed. So this term right here, 1 plus u squared, all that cubed, is equal to 1 plus u squared times 1 plus u squared times 1 plus u squared. So we have to multiply this whole thing out. I'll just multiply these two first, then whatever the answer I get, I'll multiply that. Multiply by that. So, let's start off with this. 1 plus u squared. 1 plus u squared times 1 plus u squared. And if we multiply this out, we get 1 plus u squared plus u squared plus u to the fourth, which is equal to, if you combine these two like terms, that's equal to 1 plus 2u squared plus u to the fourth. So now let's take, since this times this is equal to this right here, let's take this and then multiply it by this, and then we'll have all of this all multiplied out. So 1 plus 2u squared plus u to the fourth times 1 plus u squared, that is equal to 1 times 1 is 1. 1 times u squared is 1 times u squared is u squared. 2u squared times 1 is 2u squared. 2u squared times u squared is 2u to the fourth. U to the fourth times 1 is u to the fourth. And then u to the fourth times u squared is u to the sixth. So now we can combine like terms. U squared plus 2u squared is going to be equal to 3u squared, and then 2u to the fourth plus u to the fourth is going to be equal to 3u to the fourth. So we can combine like terms and get 1 plus 3u squared plus 3u to the fourth plus u to the sixth. So now we have established that 1 plus u squared cubed is equal to 1 plus 3u squared plus 3u to the fourth plus u to the sixth. And since what we had before was u to the fourth times 1 plus u squared and all that cubed, what we can do is we're going to take this whole thing and multiply it by u to the fourth to get, the answer to, multiplying everything out. So u to the fourth times 1 plus u squared and that whole thing cubed, that would be equal to u to the fourth times 1 plus 3u squared plus 3u to the fourth plus u to the sixth, because this equals this. So now let's multiply all this out. So u to the fourth times 1, that's u to the fourth. U to the fourth times 3u squared is 3u to the sixth. U to the fourth times 3u to the fourth is 3u to the eighth. And then u to the fourth times u to the sixth is u to the 10th. Okay, so that's that. And that's what the new integral is going to look like. That's what it multiplied all out is going to look like. Well, the new integrand. Yeah, so this is what the new integrand is. So instead of this integrand right here, u to the fourth times 1 plus u squared and that whole thing cubed, instead we're going to have the integrand. Why does this thing look blurry? We're going to have the integrand of u to the fourth plus 3u to the sixth plus 3u to the eighth plus u to the 10th. So now we're going to have the integral, like I said, of, why is that pen doing that? U to the fourth plus 3u to the sixth plus 3u to the eighth plus u to the 10 du. So this is our new integral. All right, so now that that's done, let's go on to step 8. Alrighty, Aphrodite. So, for step 8, we are going to solve the integral of the answer you just got from step 7. So what we get from step 7? From step 7, we got the integral of u to the 4th plus 3u to the 6th plus 3u to the 8th plus u to the 10th du. So basically for this step, we literally just solve this integral. So if we were to solve this integral, we would get u to the 5th over 5 plus 3u to the 7th over 7 plus 3u to the 9th over 9. Why did I write my 9 like that? That's supposed to be a 9, guys. Sorry, it looks so ugly. Over 9 plus u to the 11th over 11 plus c. Now, this 3u to the 9th over 9, this can be simplified because 3 over 9 can be simplified to 1 over 3. So we can simplify it, and then we can also write u to the 5th over 5 plus 3u to the 7th over 7 plus u to the 9th over 3 plus u to the 11th over 11 plus c. So that's it for step 8. All right, so for step 9, we're going to take the answer from step 8 and replace u, I don't know why the u got cut off like that, and replace u with tan x, and then that's your answer. And I put another smiley face just because. So the answer we got from step 8 was u to the 5th over 5 plus 3u to the 7th over 7 plus u to the 9th over 3 plus u to the 11th over 11 plus c. So basically, like we said before, since we established that u is equal to tan x, everywhere we see u, we're just going to replace u with tan x. So u to the 5th over 5 becomes tan x to the 5th over 5. 3u to the 7th over 7 becomes 3 tan x to the 7th over 7. U to the 9th over 3 becomes tan x to the 9th over 3. And then u to the 11th over 11 becomes tan x to the 11th over 11. And then plus c at the end, plus c. So, I always like to end things out with a little conclusion. Ignore that. That was kind of a typo. So, yeah, I like to end things out with a little conclusion. So, from this example, we can conclude that the integral, why is that pen not working? Oh my God. Anyway, we can conclude that the integral of tan x to the 4th power times secant x to the 8th power dx is equal to tan x to the 5th over 5 plus 3 tan x to the 7th over 7 plus tan x to the 9th over 3 plus tan x to the 11th over 11 plus c. So yeah, there's our conclusion. I also have another example of scenario 2. I did a scenario 2 example 2. In this example, I did tan x squared times secant x to the 6 dx. As you can see, m, which is the exponent of the tan function, is 2, and that's an even number. And n, which is the exponent of the secant function, is 6, which is also an even number. So yeah, I already did this example out. I'm going to upload it in the Google Drive, and I'm also going to upload the example that we just did, the first example, example 1. I'm going to upload that into the Google Drive link as well. So I'm going to put both of these links into a PDF, both of these examples into a PDF document, and like I'm going to put it into the link in the description episode and stuff if you guys want to practice on your own and like do another example and stuff. So yeah, that'll be available in the Google Drive link. All right, guys, so that pretty much sums up this topic, and I will see you guys in the next video. Thank you.